NFPA 70, also known as the National Electrical Code, Section 230.46 addresses service disconnecting means. It generally limits a service to a single disconnecting means at a readily accessible location, either outside the building or inside, nearest the point of service conductor entrance. An exception allows multiple disconnecting means where one service feeds a series of two winding distribution transformers per section 450.47 or where one service feeds 6 or more disconnecting means per section 225.38. The National Electrical Code doesn't explicitly define common location for service disconnect. The general interpretation is that the disconnecting means must be grouped in a single area. This ensures all disconnecting means for a single service are easily accessible and identified. An inspection department's interpretation that a plaque is enough for separated disconnects is generally not supported by the National Electrical Code. To comply with the National Electrical Code, relocate the second disconnecting switch next to the meter enclosure. This puts both disconnecting means in a common, accessible location. If relocation is infeasible, install a remote signaling device at the controlled area switch. This device indicates when the switch is off, remotely verifying its state without physical access. While helpful, a plaque identifying disconnect locations does not replace the requirement for a common location. The main service disconnect requirements revolve around ensuring a readily accessible and easily identifiable way to energize all power to a building or structure. This is paramount for safety during emergencies, maintenance, or any situation requiring complete power shutoff. Firstly, consider the working clearances around electrical equipment. National Electrical Code Article 110.26 dictates minimum working space requirements in front of electrical equipment, including service disconnects. These clearances ensure that electricians have enough room to safely work on the equipment while it is energized. Secondly, think about the accessibility of the disconnect. The National Electrical Code requires that service disconnects be readily accessible, meaning they should not be obstructed or require the use of tools or ladders to reach them. This ensures that anyone can quickly shut off the power in an emergency. Thirdly, focus on the identification of the disconnects. Each service disconnect must be clearly labeled to indicate what it controls. This helps prevent confusion and ensures that the correct disconnect is turned off when needed. 4. Consider the grouping of disconnects. When multiple service disconnects are allowed, they must be grouped together in a common location. This makes it easier to find and operate all the disconnects in an emergency. 5. Think about the height of the disconnects. The National Electrical Code specifies the maximum height at which service disconnects can be installed. This ensures that they are within easy reach of most people. 6. Focus on the environmental conditions. Service disconnects must be suitable for the environmental conditions in which they are installed. For example, disconnects installed outdoors must be weatherproof. 7. Consider the type of disconnect. The National Electrical Code recognizes various types of service disconnects, including circuit breakers and switches. The type of disconnect used must be appropriate for the application. 8. Think about the interrupting rating of the disconnect. The interrupting rating of a service disconnect must be sufficient to interrupt the available fault current to the service entrance. This protects the electrical system from damage in the event of a short circuit. 9. Focus on the overcurrent protection. Service disconnects must be protected by overcurrent protection devices, such as fuses or circuit breakers. These devices protect the electrical system from overloads and short circuits. 10. Consider the bonding and grounding. Service disconnects must be properly bonded and grounded to ensure electrical safety. Bonding and grounding provide a path for fault current to flow back to the source, tripping the overcurrent protection device and energizing the circuit. Let's discuss the ampacity of conductors. The ampacity of the service entrance conductors must be sized according to National Electrical Code 310.13. This section provides tables and guidelines for determining the ampacity of conductors based on their size, insulation type, and installation method. The service entrance conductors must be sized to carry the calculated load of the building or structure. Next, let's discuss the short circuit current rating. The service equipment must have a short circuit current rating equal to or greater than the available fault current at the service entrance. This rating ensures that the service equipment can safely withstand the stresses of a short circuit without failing. The available fault current can be determined by a qualified electrical engineer or using a fault current calculator. Now, let's consider the grounding electrode system. The grounding electrode system must be installed in accordance with National Electrical Code 250.50. This section specifies the types of grounding electrodes that are permitted, such as ground rods, ground rings, and metal water pipes. The grounding electrode system must be properly connected to the service equipment and the building's metal frame, if any. Furthermore, let's consider surge protection. Surge protection devices should be installed at the service entrance to protect sensitive electronic equipment from voltage surges. These devices divert surge current to ground, preventing it from damaging equipment. Surge protection is especially important in areas that are prone to lightning strikes. Let's talk about the importance of coordination. The overcurrent protection devices in the service equipment must be coordinated to ensure that the device closest to the fault will trip first. This minimizes the extent of the outage and prevents unnecessary damage to the electrical system. Coordination studies can be performed by a qualified electrical engineer. The National Electrical Code requires that all electrical work be performed by qualified persons. This ensures that the work is done safely and in accordance with the code. Unqualified persons should not attempt to perform electrical work. Service disconnects should be inspected and tested regularly to ensure that they are functioning properly. This includes visually inspecting the disconnects for damage, testing the operation of the disconnect mechanism, and verifying the tightness of connections. Regular maintenance can help prevent failures and ensure the safety of the electrical system. The National Electrical Code is a complex document, and it is important to consult with a qualified electrical professional to ensure that your electrical system complies with the code. Failure to comply with the code can result in fines, penalties, and safety hazards. The location of a service disconnect is a critical aspect of electrical safety and code compliance. It's governed by specific requirements to ensure accessibility and prevent hazards. Firstly, the National Electrical Code mandates that a service disconnecting means should be installed at a readily accessible location. This location can either be outside the building or structure or inside, nearest to the point of entry of the service conductors. The primary goal is to provide a convenient and safe way to disconnect power to the entire building in case of emergencies or maintenance. Secondly, the term readily accessible implies that the disconnect should not be obstructed by any obstacles such as stored materials, locked doors, or anything that would hinder immediate access. The disconnect should be easily reachable without the need for tools or special equipment. Thirdly, in situations where a building has multiple tenants or occupants, each occupant should have access to their respective service disconnect without having to enter another tenant's space. This ensures individual control and safety for each occupancy. 4. The height of the service disconnect is also regulated by the National Electrical Code. Typically, the disconnect should be installed at a height that is easily reachable by most individuals, usually between 4 feet and 6 feet from the finished floor. This height requirement promotes ease of operation and accessibility for all users. 5. The service disconnect should be clearly labeled to indicate its purpose and the area it serves. Proper labeling is crucial for quick identification during emergencies, allowing individuals to disconnect power to the appropriate area without confusion. 6. In some cases, a building might have multiple service disconnects. The National Electrical Code allows for multiple disconnects under specific conditions, such as when the total number of disconnects does not exceed 6 or when dealing with large capacity services. However, even with multiple disconnects, they must be grouped together at a readily accessible location. 7. The location of the service disconnect should be free from environmental hazards such as excessive moisture, corrosive substances, or extreme temperatures. These conditions can damage the disconnect and compromise its functionality, potentially leading to unsafe situations. 8. The service disconnect should be protected from physical damage. It should not be located in areas where it could be easily struck by vehicles, equipment, or other objects that could compromise its integrity. 9. If the service disconnect is located indoors, the area around it should be well lit to ensure visibility and safety during operation. Adequate lighting helps prevent accidents and facilitates easy identification of the disconnect. 10. Local codes and regulations might have additional requirements for the location of service disconnects. It's important to consult with local authorities and inspectors to ensure compliance with all applicable codes and standards. When considering the interpretation of common location for service disconnects, several key factors come into play to ensure both safety and compliance with the electrical codes. Firstly, the primary intent behind the common location requirement is to ensure that all disconnecting means for single service are easily accessible and can be quickly located in case of an emergency. This is crucial for first responders, maintenance personnel, and anyone needing to de-energize the electrical system. Secondly, the term common location generally implies that the disconnects should be grouped together in a single area, rather than being scattered throughout the building. This grouping facilitates easy identification and operation of all disconnects associated with a particular service. Thirdly, while the National Electrical Code doesn't provide a precise definition of common location, the interpretation often depends on the specific circumstances and the judgment of the local electrical inspector. However, the general consensus is that the disconnects should be within sight of each other or, at least, in close proximity. 4. In situations where disconnects cannot be physically grouped together due to space constraints or other limitations, alternative solutions may be considered. These solutions might include installing clear signage indicating the location of all disconnects or utilizing remote operating mechanisms that allow all disconnects to be controlled from a single location. 5. The use of a plaque or directory to identify the location of disconnects is a helpful practice, but it does not necessarily satisfy the common location requirement. The plaque serves as a supplementary aid but should not be considered a substitute for proper grouping of disconnects. 6. The interpretation of common location may also depend on the size and complexity of the building or facility. In larger buildings, disconnects may be located in different electrical rooms or areas, but they should still be arranged in a manner that allows for easy identification and access. 7. The electrical inspector has the final authority to determine whether the arrangement of service disconnects meets the requirements of the National Electrical Code. It's essential to work closely with the inspector to ensure that the installation complies with all applicable codes and standards. 8. The common location requirement also applies to multi-meter installations, where several meters are grouped together to serve different tenants or units within a building. In these cases, the disconnects for each meter should be located in close proximity to the meter bank. 9. When evaluating the common location of service disconnects, it's important to consider the potential for confusion or ambiguity. The arrangement of disconnects should be clear and unambiguous, leaving no doubt as to which disconnect serves which part of the building. 10. In some cases, it may be necessary to install additional disconnects or modify the existing electrical system to comply with the common location requirement. These modifications should be performed by a qualified electrical contractor in accordance with all applicable codes and standards.